Okay, thank you. Yeah, I've put a few buzzwords in my slide title. Thank you all to be attracted to that. Let's first start with a few mandatory slides. Introducing myself, my name is Koen van Nees. I'm Security Operations Manager at Sigeka. I've also put my contact details. If you have any questions afterwards that could not be answered, just let me know. Yeah, introducing Sigeka, but I'm not going too much into detail. We are an IT service provider. That means that we also deliver security services. Um, and yeah, that's a bit the context that we are looking at in this presentation. Another few more words about the context, just to make sure that the title didn't distract you too much. We will not really talk about latest machine learning techniques. This will also not be a vendor presentation about the newest and fanciest AI features. But what it is supposed to be, or what I will try it to be, is just some ideas on how a standard security operations center is evolving lately, more evolving towards DevOps, and then specifically how we will tackle that from a cultural point of view, because the challenges and so on, we see that it's increasing a lot. Yeah, I base myself not only on my experience, but also on what literature says. I've just formed here a few quotes. The last one maybe is interesting. If you make a decision as a human, it's always with a certain bias, while a machine decision should be more accurate. Now, this is a bit controversial because in cybersecurity that makes total sense. But for example, with automatic cars, that's a bit harder. You know, the classic dilemma if you have to choose between hitting a mother with child or a tree. That's different, of course, but on a purely technical level, like security, it makes perfect sense. And the last quote is from something that maybe makes it all more obvious. If a lazy engineer has to do a certain thing twice manually, well, he should have automated it. And I think that should be more and more on the back of our minds if it is not there already. Now, there are different ways to represent how a security operation center evolves. I choose it to do it here is with the amount of data over time, but there are different other approaches. But what I see is that when I started in security, that was 10 years ago, it was very much function driven. With that, I mean a network engineer with some security interest looks at his job from more security point of view, looking at what his firewalls are doing and so on. It was something more optional, let's say. And then more and more it became a compliance-driven activity. ISO became more and more a thing, and it drove security to raise a little bit in maturity. And with that, also the amount of data also increases. Then management concerns grows, and typically that is triggered by security incidents or just global awareness that increases. And while we are growing maturity, while we have more and more data, it is also becoming more an improvement-driven activity, always adding new data, correlating, enriching, connecting multiple sources. And we are, I think, more and more looking at a data-driven approach, where every security professional, every security engineer, every security analyst, in a sense, is a data scientist. Everything is data in security operations. And that is a bit the background of what I'm trying to, what my message is. There's also a classic approach in IT, but also in SOC. You should, the idea behind that is that you should spend as much effort, uh, resources, money on the three aspects: people, technology, and processes. I'm not saying that it's outdated. It will always be something that we have to strive to. But what I believe that the SOC is more and more evolving to is automation and intelligence should be more in the DNA of a security operations center. And I made the bubble people bigger uh, with some intention, because it's classic that people get afraid to lose their job because things get automated, because the robots are taking over our jobs. I believe that's not true. I believe that to make the whole concept a success, the people are even more crucial. You have to make the automation and the intelligence work. You have to have the right skills, the right resources, and that makes the people even more important. And that means also that we have a demand for new skills to achieve that. Um, this is not shocking, I guess, but scripting skills for a security operations engineer is a must. And I would specifically mention Python, also not a surprise, I guess. But Python also has a very broad range of libraries to deal with machine learning, artificial intelligence, which makes it the barrier to start with it pretty low, and actually potentially everyone with some scripting talent can start with it. While a security engineer or analyst, up till recently, I think, was very much focused on response and dealing with rules, fine-tuning, mostly the output of a SIEM solution. I think it's important that they take care of all the components, also data ingestion, enrichment, seeing that all the components that you build in a SIEM operate at all times, so that your automation and your intelligence is always working as you expect. And most of all, don't look at security as a very narrow thing, but also look at techniques and trends that go beyond the comfort zone. And now I specifically mean DevOps-like techniques. So now a few words on how we try to do that at Sehega. So at all times, SIEM is central, and we are typically using Splunk for that. But any SIEM with a decent API should be okay. So I'm not going to promote any SIEM or demote any else. Next to that, Jenkins is also important to automate your job scheduling, to start processes, to automate what you are trying to do in terms of intelligence. Selenium, and that's specifically where DevOps-like features come into place, is to check what's happening on the front end of your SIEM. You build reports, you build dashboards. It's common practice in the SOC, but it should operate at all times. And lastly, it's Jupyter Notebooks. As I said, scripting is crucial. And I've become a real fan of Jupyter because it brings out something extra, and let me explain why. Jupyter is actually a interactive computing environment. It supports multiple languages, but again, I would recommend starting with Python. And it makes your scripting and your development very visual. Especially if you go to machine learning, it's very important that what you're doing, learning techniques and so on, is always visual, so that you have an idea of what your job is doing actually. And Jupyter is really perfect for that. And that makes actually your scripts human readable and understandable. Data analysis becomes very visual. And that's the architecture. So again, of course, SIEM is central. Jenkins is also important to start multiple jobs through Selenium versus SIEM itself. or to Jupyter to execute code versus SIEM to collect data, and to publish it to reports, give extra insights, and specifically machine learning models. And it's important that there's always a cycle and that you use the output of a Jupyter report or a Jupyter notebook to improve what you're doing in SIEM. Because I strongly believe if you stick to the SIEM front end, that cycle is not always good enough. And I'm going to focus on 3 aspects. I could have added multiple more, but I selected the 3 that are the most obvious ones. So how could you use this architecture to improve what you're doing in a SOC? Well, you could use it to visualize what you're doing a little bit more, to validate what you're doing, and also detection, and then I'm talking about machine learning. And I will go over them one by one. So what's the challenge when we try to visualize things as a SOC? Is the fact that today's logs are huge in amount and increasing every day. Also, the complexity is increasing because you won't enrich one data source with the other. There are dependencies. You can do that with SIEM, I'm totally aware of that, but the visualization sometimes is limited. Also in a SOC, there is always some job path, a job cycle, and for junior analysts, it's a lot easier to understand what the SOC is doing, what the operation is if that's visual. A drawing is worth more than 1,000 words, they say, but a graph is worth more than 1,000 logs. That's a bit the idea. And to give you an example, this is to the left a list of Sysmon logs. Sysmon is actually a sysinternals tool maintained by Microsoft that actually enriches your Windows event logs. And what it typically in this example does is looking at process initializations and also registry edits. And it's typically pretty hard to make it visual how the process tree looks like in a SIEM solution. I know there are other tools which can achieve similar things, but in Jupyter it makes it a lot more easier because you see the code, you can enrich on the fly and see the effect immediately. So on the right is how that could look like in Jupyter. You see different processes, first process starting the second one, which is then changing a registry, which is of interest for us. And this is just an example. Another example that we used, for example, is to investigate phishing attacks. So then you start with a log file, your email gateway or your Exchange logs, and then you can determine who received a certain phishing email. And you can enrich that with browsing log sources and see who actually clicked a certain link and who actually ran a code. And if you combine that in a process tree, you have very fast an idea of who trapped into a phishing attack. And that's a bit the idea of a Jupyter notebook that can be reused and can be adapted easily if you have small changes in your attack scenario. Then validation. I think, and that's nothing new, if you build dashboards, if you build correlation searches, even if you use it directly from a library that the SIEM shows or provides, you always want to make sure that it is operating at all times. All components of the SIEM should actually be validated continuously, and I'm going to point at 2 examples. You need to validate the correctness of your dashboards, but also of your correlation searches. So first of all, you want to validate your scenario or your correlation search. What you actually want to do is you have a list of predefined events, and you do all this actually through the SIEM API. You get the correlation search through the API, and you check if the predefined events and the correlation search have the expected output. So for example, here in the left below, you see that we have certain command line processes, two events. The correlation search looks for a specific encoded command parameter. So if the correlation search works, it gives one event as output. If something breaks in the correlation search or whatever, because that's a dynamic thing, then this test, which you can do through Jenkins, would not provide that one event as output, and you can conclude that your correlation search is broken. It happens it happens a lot that such a situation where correlation search is broken is only discovered after days or weeks, and that's of course a situation that you do not want. So typically you can run this job every hour and see if someone by accident or for whatever reason breaks something that has an operational impact. A second example is to validate your dashboard or your report. You build reports that are needed to do threat hunting or to report to management or whatever. And for that we use Selenium, which is actually a framework to automate all your web browser tests. So if someone breaks something in a dashboard, and again, that's mostly human error, but it could also be that for some reason there are no events anymore visible, then Selenium is able to detect that just simply by, it's not very obvious, but simply by looking at any error messages on a dashboard page. And how that typically works is that it's just a piece of Python code. In the first step, you just get the Splunk URL. You do the authentication in the second part, and then you just load the dashboard that you want to check. And if you wait a little bit, because typically there are some dashboards that take some time, and then you assert if the dashboard was loaded without any error being printed out in the browser in the session. That is very simple. That's something that in DevOps is happening all the time. But what I think is that you should use it in a SOC more to improve efficiency. And then detection. The idea behind that is that the standard correlation rules are typically outdated. It's always a quest for what is now the perfect threshold. You have to change that every time, and situations change, environments change. It's just not at all efficient. So there is always a need to talk directly with SIEM through an API, because you want to put this kind of intelligence outside of it. I'll explain you why. You have to design models. You have to set up your own machine learning scenarios. Most SIEM solutions already have a machine learning capability that's not loading very well. Sorry for that. But you have no real insight in how the training process is actually happening. You just set up the machine learning job. You have it sets up a standard model, but what happens on the background, it's not very visible. Therefore, you also don't know if it's doing actually what you want it to do. It also is limited in terms of available models, in terms of model parameters that you can use to do your job on. It's also very difficult to combine different models, and especially that is very helpful. Basically, the conclusion is that if you look at standard SIEM technology, the automated learning or the machine learning is still under development, and I believe that's not ready yet. Maybe that's a bit controversial because it's mostly from our experience that we make this conclusion. Maybe there are other vendors that are better, but I believe there is still something to say of doing it outside SIEM. Let's take a very simple example, just a vertical port scan. That's one IP, which scans multiple ports on one host. That's a standard thing that should trigger something in a SOC. And if you look at the standard way of dealing with that, then we set up a certain threshold. If 200 ports are scanned from one source IP to one destination IP, then it could trigger something, or any other threshold. It's just an example. But the thing is that you can bypass that very easily if you do it on a slow scope, or if you stay under the radar just enough. And most of all, it's a lot of false positives because some IPs just, for some reason, do this kind of things on the network. And it takes a lot of time to actually improve your correlation search with some whitelisting, etc. To deal with that. It's just not efficient. And if you do that with machine learning, and the clue is actually to combine two machine learning techniques, is to first of all create profiles. And you do that with a technique called k-means clustering. Then you group IPs that have a similar behavior in one cluster, in one group. And the second job would be to use a dynamic threshold, but you can do that then for each profile. So if you have a group of IPs that are just very noisy on the network, that group would have a different threshold than a group of IPs that are typically, for example, workstations are pretty silent when it comes to looking at multiple ports on one IP. And with Gaussian anomaly detection, you have then you can detect an anomaly if it goes a certain deviation away from the mean value of that cluster. And especially that combination, the clustering and the anomaly detection, that's what no SIEM can do in a very efficient way, and where you can use frameworks like Jupyter. Most of all, the nice effect is that the number of false positives, and we can actually confirm that, is a lot lower. And once you set that up, it's very easy to maintain. So if you set up k-means clustering with 10 profiles, you have 10 groups, you have 10 dynamic thresholds, because it learns and it defines different thresholds all the time. And as I said, if you want to do that in SIEM, you have to have these different jobs and different machine learning jobs in SIEM. You have to combine them. It's very cumbersome. It's very hard to maintain. So I would go for the architecture on the right and speak with the API in SIEM, do your machine learning, and produce results back to SIEM so that you can respond to it, just like with any other scenario. Then it's time for a conclusion. It was my idea to give some things to think of, because I believe we always should expand our mind and our scope and our way of working. I believe that the threat landscape and what's customers and what we expect from SOC ourselves demands more and more for higher and different focus. It's not only events in, alerts out, response. We have to always look at more efficiency. So repeating tasks need to be automated. Cannot stress that enough. It's scripting and automating is a standard skill for any security professional. Also, the quality should always be evaluated. The things that I showed around validation, it's just two examples, but you can use these techniques for different components in your SOC. And most of all, machine learning, it's a buzzword. I'm very well aware of that, but I believe that's the next logical step in improving ourselves. The threshold, let's forget about that. Let's go for advanced detection scenarios. And to conclude, finally, is I believe that the typical DevOps qualities and skills become a very important part of a SOC's engineers tool set. So what we should do is always expand our skill set and our scope, and think about what typically is done in DevOps. That's it, actually. Thank you.
So thank you so much for the awesome presentation. I think we definitely have time for a few questions. So let's get it started. Yes, we see you. A mic is coming to you, to your right.
So should I stand? Yeah, so first of all, congrats for the presentation. Questions. I agree with the statement. I fully agree with the statement that you had in one of your slides regarding like if you're doing something manually twice, then you should definitely think to automate. But my question for you is like, how could you enforce having SOC for a product which is currently in development? So what you said is kind of tricky to implement when you're actually developing something. Obviously, if the product is mature enough, you can think about automating something like having a good architecture, as you said. But like if the product is in a continuously changing environment. For example, you mentioned about Selenium, right? So if you are thinking about a website or something, web platform, right? So you have all these components which in a development phase might change a lot. So in that case, automation not necessarily makes sense like all the time. So it's kind of tricky to automate, not to mention machine learning if you're having a quite dynamic, environment, So how would you approach that? I mean, as we all know, in the software development lifecycle, it's much more effective to apply stuff, to solve stuff in an initial phase. So not after you release it, from different kind of point of views.
Yeah, I completely agree. That's pretty tricky, but I cannot say I have the exact answer for that. But if you are in the development process and already think about automation techniques and responsibilities or automation opportunities in that phase, I believe whenever you execute it, it's always interesting. So my advice would be to do it as fast as possible. And typically these things that I propose, you can reuse parts of it in other situations. So if you have a standard set of automation and tool sets, then it should go easier. But it's difficult, I agree.
Yeah. So overall, basically, you can apply all of this when the product is mature enough. But then it's the risk of not having security in an initial point of the product, right?
Well, security, of course, is always the number one priority.
It is, but
it's it's a balance that you have to look between delivering a secure product and a product that also operates tomorrow and next week and next year. And I think what you should do is during development already work on that and look for the right balance that fits with the expectations of the customer.
Okay, thank you very much.
On to the next question. I know we have several there, so if you could, yes, thank you.
So, Harper, thanks for the presentation. I have actually two questions. So one of them is what you ensure or how can you make assurance that your integrity is not altered while correlating logs? So that's one of the things, because you're scripting and correlating logs. So whenever you alter the logs, there's a risk for that to be corrupted, for tampering and whatever. The other thing is, what do you think? How can you make a SOC for different products? So especially when you have a service, the product is the same. Yeah. But say, for example, your company does, I don't know, web design. So today it's a web service for someone. Tomorrow it's going to be a meeting app. The other day is going to be something totally different. So how do you imagine that, I don't know, approaching?
Yeah, I'm not sure I understand your second question.
So
But,
if the product is not the same,
Yeah.
so every time it's different, your logs are going to be different, your problems, your errors, they're going
We're
to be
still
different.
talking about the scene, actually. So
Yes,
the
still
scene is
about
monitoring
SAM.
different things.
Yeah,
Yeah,
but
okay.
SIEM goes with monitoring, obviously.
But that I will respond to your first question first. Integrity is, I think, always guaranteed because if you look at my architecture, it's only reading that it does. It does not write at any point. It just grabs the data,
Yes.
does its thing
It's
in
in
Jupyter.
processing. So it's in processing.
Yeah, processing it, and then you can write to another index or another destination in your SIEM. So that way you can always assure that integrity is not at stake. And your second question is pretty relevant to what your colleague asked. I think when you're monitoring more and more, you should, I think about these techniques while you're developing, while you're onboarding them, and reuse as much as possible the code that you already have. And that's tricky again, but yeah, that's also what's tricky in DevOps.
Super stuff. Thank you.
Thank you.
Next question. We have there, and then we're going to go on the other side, I promise.
Hey, so thanks a lot for the nicely done presentation. And so I have one question, and it's mainly regards if you did any attempts to tag the machine learning models to a MITRE attack framework.
Mm-hmm.
And if you did it already, are you planning to publish it open source or not?
We did not do it yet, and we can think about that. It might be interesting. For us, it's also a very recent and very new approaches that we are doing. So, but I will keep it in mind.
Yes, I believe that these attempts will be quite beneficial if basically for targeting SOCs, which are handling with a really broad and big infrastructures.
Yeah. Okay.
Yeah.
Thank you.
And if you release it open source, that will be, really great for the whole community.
Thanks for the idea.
Yeah.
Awesome. Let's take, yes, that question over there.
Hello. So in the beginning, you said the importance of the human aspect in the development. What do you think about testing? Do you think testing can be fully automated? Because some people think that it can be not, because testing should be about finding the human intention. And that would mean having the perfect AI.
I think you should automate it as much as possible, but yeah, there'll always be a human intervention to evaluate that process continuously. So it's a bit chicken egg situation, I think.
Okay, thank you.
Cool. Next question. The mic is coming to you. Just keep your hand up, please. Okay. We have time for two more, so don't worry.
Can you please give us two concrete examples of other machine learning things that you could solve? I mean, you gave us just the IP scanning example.
Mm-hmm. At the top of my head, let me get back to that. It's typically something that I should address to my engineers, so not directly.
On to the next question.
Or, for example, brute force attempts or so. Typically, everything that has a fixed threshold is, I think, the first focus of a machine learning job. Because that is just too stupid, pardon my French, but everything with a fixed threshold, like a brute force or a port scan, yeah, you should try to look at it in a machine learning way.
Okay. Cool. Taking the next question over there.
Okay, thank you for your presentation. You've mentioned the possibility of eliminating the hard-defined thresholds. And as an alternative, you've mentioned k-means clustering as a means of unsupervised learning.
Yes.
The k-means algorithm has some built-in parameters that you need to define before analyzing the data. So instead of defining the 200 open ports for that threshold, you've switched that to the number of clusters in the k-means with the 10 clusters. That was something that you empirically find to provide good results for that case, or you hope to generalize that number of clusters to somehow identify the number of clusters in advance?
I think that first step is crucial for reducing the false positives. You could stick with only the second machine learning jobs and just look at what is an anomaly based on just one group of IPs. But because in a typical network, there are so many different kind of devices, I think you still have too much false positives. That's what I think. That's also what our tests prove.
Awesome. Well, that's a wrap for this presentation. So thank you so much.